The Outer Banks, North Carolina, is a popular year-round tourist destination made famous by the Wright brothers and the advent of flight. And its unique series of barrier islands, it's also home to the Dare County Regional Airport, originally established as a Naval Auxiliary Air Station used for special training of squadrons flying F-4U Corsairs. Officially commissioned on March 3, 1943, the U.S. Navy utilized the site as an auxiliary training field and fuel storage complex during World War II.
The history of the area is unique, and then, of course, the Wright brothers with first powered flight in 1903. They did coastal patrols here in World War II.
We are working at the former Naval Auxiliary Air Station Manio in Manio, North Carolina. It had fuel lines and underground storage tanks that caused an environmental spill. So what we're doing right now is cleaning up along those tanks and along the pipeline.
In 1947, following the war, Dare County asked for the return of the airfield. Since then, the facility has been operated by a fixed-base operator, and later the Dare County Airport Authority, which took over the airport in 1983 and continues to oversee the airport's daily operations. In 2008, due to leaking underground storage tanks, a contractor removed two 50,000-gallon USTs and four steel USTs previously used to store fuel at the site. Additionally, 455 tons of hydrocarbon-impacted soil and approximately 300 tons of sludge were excavated during the tank closure activities. Sampling performed at the time of the UST closures identified hydrocarbon-impacted soil at the locations of the concrete tanks and along the fuel distribution pipe.
We've been on this site since 2007. We originally removed the tanks and the pipes that were associated with those tanks, and we've done monitored natural attenuation since. Recognized some rebound and are looking for different approaches, and we found this product that we're using, and we think that that may help us remediate the site and close it sooner.
A comprehensive site assessment, or CSA, was performed in February of 2009 to delineate the extent of hydrocarbon-impacted soils which exceeded groundwater standards. In March of 2011, the responsible party removed an additional 1,366 tons of hydrocarbon-impacted soil from the site as part of its soil and groundwater remedial efforts. The overall objective of the ongoing remedial activities is to gain site closure by exhibiting 4 consecutive groundwater sampling events showing concentration below applicable North Carolina groundwater quality standards.
In this site, we're using a grid approach where we've put down a 6 by 6 foot grid, so every point is 6 foot apart from the next point, and we are injecting PetroFix into the ground. The numbers on this site are very close to the RSBLs. We're just trying to get past that point. So hopefully this will get us down below the RSBLs and keep us there so we can close the site.
In the process of their thorough evaluation of viable remedies, the responsible party specified PetroFix micron scale liquid carbon amendment to be applied to quickly and effectively address the contaminant levels and achieve their site goals of no further action.
It's August, and we're doing our first PetroFix injection. We are planning on doing our first sampling event in October and another in January, and we're hoping to see if we can get some fairly quick results from the PetroFix so that we can brief that back to the regulators and the other stakeholders.
Regenesis has put together online design software to make our customers expert at remediation. What we've really done is we've taken all of our experience over many, many years and our knowledge of PetroFix and boiled that down into a guided online solution that gives our clients output very similar to the same output that we put out ourselves when we do the designs, except they can do this autonomously and with little time.
The design developed incorporates 4,800 pounds of PetroFix for a total of 23,337 gallons applied using direct push injection to 12.5 feet below ground surface. Also important to the work was to document that PetroFix was successfully being injected and distributed through the subsurface. By using Regenesis's detailed documentation on applying PetroFix, the field personnel oversaw that equipment needed for the injection was obtained, such as multi-port injection tooling, and that observation soil cores were taken pre- and post-injection to document PetroFix distribution at the site. Based on visual confirmation of PetroFix in soil cores or observed in monitoring wells, the field crew was able to determine if PetroFix was being successfully distributed, and if not, to make real-time adjustments to injection tooling, injection volumes, and injection pressures to accomplish the distribution goals for the project. Safe, fast, effective, and easy to apply, PetroFix is designed to specifically sorb and biodegrade petroleum hydrocarbons, PHC, diesel, BTEX, MTBE, and TPH-G. The field crew plans on closely monitoring the site and are using PetroFix on other CERCLA/RCRA funded sites to quickly reduce levels and accelerate site closure.
PetroFix is different than the other technology we've used because it binds with the hydrocarbons, and the electron acceptors allow the bioremediation to break down the hydrocarbons. Once we've conducted the injections of the PetroFix, it's fire and forget. We don't have any other technology that remains on sites that would be disruptive to the facility.